So thanks for coming to our talk on PowerShell is Dead, Epic Learnings. So what we're going to talk about, we're going to do a bit of an introduction. My name's Ben and this is Doug. Talk you to a little bit about what is PowerShell, when people say what is PowerShell, all the different key components of PowerShell, and whether it is or is not dead. We're going to talk a little bit about the evolution of POSH 2, which is a command and control framework written purely in PowerShell by myself and other members of Netitude. We're then going to talk a bit about EDR, some of the history and challenges we face on the offensive side, as well as some of the stuff on the defensive side. And then a couple of future predictions and hindsight, to where the industry is going from an offensive perspective. So who am I? So my name's Ben Turner. I head up the Netitude Red Team, so I have direct oversight of all the Red Team engagements that happen. I do get involved from time to time, but I've tended to step away a little bit now and just to kind of have oversight of all the engagements. I am a Crest CSAS and CTL and have been for many years. Done some Red Team training that we've delivered at SteelCon for the last couple of years. Also done some workshops on red teaming and stuff like that as well. I've done a few talks as well in the past, so if you want to check them out, I'll put a few links there. And also the lead developer of POSH 2, which we'll talk a little bit later about today.
I didn't realise the intros were going to be so long, so I decided to keep mine short and sharp, and then when I saw Ben's, I thought, damn, I better pad mine out. So I padded it out with a nice wee picture of me. But basically, I'm a principal security consultant at Netitude, one of the Red Team leads. We have multiple Red Team leads who carry out offensive engagements following threat intelligence red teaming against large banks and insurers and things in the UK and abroad.
And also, you may have noticed we're called Team Spicy Weasel, so we attend the DerbyCon CTF every year. So a bit sad that it's the last year this year. We've had first place for the last couple of years. I'm going to hope for the trio this year. But there's some good write-ups if any of you are interested in CTFs. Some quite good challenges. We quite like going out there as a team and challenging ourselves. So if you want to take a note, there's some of the links. We will make the slides available for everyone a bit later on slideshare.net, so you can grab them if you don't get a chance to get the links now. So before we get going, I just wanted to reference a few tools and books that we kind of use on a daily basis from an offensive perspective. I'm not going to point out them all because we'll make the slides available, but Process Hacker, which is a bit like Process Explorer, is one that I use pretty much on a daily basis. There's going to be a couple of screenshots with this in. It's got a couple of good features above Process Explorer, things like you can see the tokens and the threads, and you can manipulate those within Process Hacker itself. And it's got some quite good viewpoints from a .NET perspective, which I'll show you a little bit later. We do quite a lot on the process migration injection when we're doing red teaming. And being able to sort of see the pages in memory is a really great way for us to know whether things are happening or not happening. So VM map is a great way for us to do that, and that's all available from sysinternals. Also, CFF Explorer from NT Core, that's another really good application I have on my Windows box. So any DLL, any executable, you can right-click, open with CFF Explorer. You can see all of the binary output, all the hex. You can see the exports in a DLL. You can patch them on the fly. So it's just a really good tool that we use quite regularly when we're doing sort of reversing and that kind of thing. And another one, if you're not familiar, is proxy cap and proxy chains. So from a red team perspective, if you've got a SOX proxy, this allows you to use any of your tools that are sort of your side against your target. So even things like graphical, so like RDP or Telnet against sort of mainframes, that kind of thing. You can do all this via using sort of proxy chains and proxy cap. Another couple of books that I just wanted to reference as well. So I've been pen testing for quite a few years, but I wanted to kind of get a bit of a lower level knowledge of the Windows API calls and tokens and handles and how this all works. Windows Internals book part 1, which I recently got, and I'm sort of halfway through it. I think it's a really good reference book. It kind of dives into some quite low level knowledge, but kind of starts to click a few pieces into place for me when I'm actually sort of doing things like process migration and stuff like that. So I think it's a great way to learn. Also the red team and blue team field manual. So I think the more we can know about the defensive side, the better we can do offensive work for our clients. So if we know how they think and how they work, we can work around them and talk about avoidance techniques, which Doug will sort of talk about a little bit later in this talk. And also the Hackers Playbook, quite like that one, mainly because POSH 2 is in there, so I was quite chuffed with that this year. So the sort of crux of the talk is what is PowerShell and is it dead? I think when a lot of people say PowerShell's dead, a lot of it's come down from like I guess the elites of the offensive world starting to move over to sort of C# and .NET. But when people say is PowerShell dead, I think you've got to think about it in many different ways. So do they mean just directly the PowerShell executable? So if you see this running on a box, is that malicious? Is that what they say is dead? So you can no longer run standalone PowerShell executables on a Windows host because they're blocking them. Is that why it's dead? Is it actually the system.management.automation DLL? So that's the crux behind PowerShell. So PowerShell is just a wrapper for this DLL. So is it when they say PowerShell is dead that they mean that? And now because you've got other techniques from EDR that can detect anything that's loaded into that process, that they can now monitor for this. So is it that they think is dead? Or is it the folder? So is it the folder that the executable is launched from? So if you move the folder from there to sort of ctemp, does that mean now you've got free reign again to run things like PowerShell as long as you call it something else? And also, since the introduction of version 4 and 5, a lot more advanced security features have been implemented in PowerShell. Things like transcript logging, script block logging, AMSI integration, which allows AV vendors now to scan PowerShell and all of those one-liners. So that was a lot of the ways that people were getting around it. And threat actors were getting around it was basically you've got direct access to memory, so you can get scripts loaded into memory without getting scanned by AV first. So is it that PowerShell v2 that doesn't have any of these are fine, and PowerShell 4 and 5 is dead? So I just wanted to sort of put those key concepts into your mind, and we'll talk a little bit about them a bit later. Which brings us on to sort of the evolution of POSH 2. So POSH 2 is a command and control framework. It was purely written in PowerShell to start with from a completely client-side and server-side perspective. So you would install it on the Windows box, and you would target Windows infrastructure. It's later developed into sort of Python from a server side, but we'll talk a little bit about that in a sec. But it was mainly written, I guess, from my perspective, just because I wanted to learn how command and control frameworks work. I wanted to understand how you get a command from over here to talk through a proxy, through the internet, through redirectors, back to your host, and make it all work, make it all secure. And I guess it started out as pretty much 60 lines of code, and it was just basically a netcat reverse shell. Into what it is now, which is probably tens of thousands of lines of code with sort of multiple people helping develop it. And it's actually quite a good framework. And a lot of people think that because it's called POSH 2, which probably doesn't do it any justice, it's just a PowerShell.exe framework, or actually it's a lot more, and we'll talk a little bit about that now in the evolution. So we've been going at it for about 4 years in terms of writing and developing POSH 2. It was first developed in PowerShell from the server side and client side. In December, we released version 2. We had a C# GUI. It looked a little bit like Armitage in Cobalt. There was a lot of right-click, get system, right-click, get screenshot, that kind of feature. What that ended up was being more of a pain in the ass, to be honest, because you had to sort of maintain 2 forks of the project. Every time you make an update to the command line part, you had to update the GUI part, and it was just a bit of a mess. But it was a good learning experience, I think. We learned a lot from it. And when you're really an operator, you're really hard at it, you just want command line. You just want to know what you type in and what you get back. You don't have to be waiting for GUIs to sort of propagate, waiting for sort of things to appear. If you do something on command line, you instantly get the output back. And that's what we found was most useful when you're really hard at it from an operator perspective. We also introduced things like a POSH 2 Slack channel. And in October of 2017, we actually released the Reflective DLL. So this is, for those who don't know, it's actually loading managed code, which is basically what PowerShell is, into an unmanaged code space. Stephen Fewer did kind of all the crux of the work behind it, and we just kind of used that code to build into POSH. So what that meant now is if you're running in a PowerShell.exe process, you can migrate out of that into any other process that's owned by that user. And that means then, from a detection perspective, they have to get a little bit cleverer on how they start detecting things. And this is where the system.management automation DLL starts to come in. We also released Sharp Socks at the tail end of 2017, just after DerbyCon, so a guy called Rob Maslin. So that allowed us to basically have a complete Socks proxy through POSH 2 that allowed you to do things like RDP. So before, it was very much command line driven, so you can load PowerShell scripts or anything that's sort of on the host itself. But with Sharp Socks, you can deploy that. It will all be done via HTTP or HTTPS beacons, all encrypted, and you basically can be running an RDP session to their domain controller through a compromised host. So that was a really big opener for us from a POSH 2 perspective. And also in 2017, we migrated over to Python. So from a C2 server perspective, it was a lot more, I guess, easy to implement, because a lot of us as offensive guys want to be on Linux because you kind of know what you're doing on the command line. So we were on the C2 server side to be able to be used on a Linux side and not just a Windows. So we moved it over to Python. Very much the client and the implant side is still PowerShell driven. But from a C2 server, it just meant it's more manageable, and you can move it over different platforms as well. In 2018, we actually decided to do some documentation. So 2 years in the making, never had any documentation really, so we thought it was about time. And we also released a Python implant. So now what was actually originally only PowerShell has now gone to Python, and now you can get a Python implant. So actually you can get over a shell back by on a Mac and things like that. So we've been doing engagements where, because Cobalt doesn't seem to do Mac, Empire, the YRE one does, but there was nothing out there that we could get our hands on and actually, make our own. So we kind of introduced this within Poshy 2 as well. And then in 2019, which we'll talk about at the end, is basically a Sharp implant. So getting up with the cool kids, we decided to write a Sharp implant for Christmas. Over my Christmas holidays, thought there was nothing better to do than write a Sharp implant, which we'll talk about. And also, not that you probably want to use it or you think you have any clients that have 2003 and XP, the C# version does actually work on that as well, which is quite amazing from our perspective.
I think it's also just worth saying it wouldn't be there if it wasn't a thing.
So this is what the C2 server looked like. You have an implant handler and a server, and you basically get the implants on the right, and on the left you see the output. So it's very simple. You open a Windows box. This is, again, the 2016 release. So you have almost have split screen. One on the right shows your implants coming in, one on the left shows your output, and you get logging. Logging was the kind of key important part about all of this. The reason why we made it was because everything you do needs to be logged from a defensive perspective, so that when we go to the client and say, we did all this against your estate, they can then learn to work with that and kind of make their detections and put them in place to what we actually did. And the timings are really quite important. So if you don't track your logs accordingly, then obviously you're giving the false data to the client, which isn't helpful for them when they're trying to track back through all their logs of all their different systems and actually play back this as more of a purple team exercise. So again, back in 2016, what did PowerShell look like when you had compromised a host? So I don't know if anyone can see what's wrong with this, but quite simply, there's a PowerShell one-liner running there, sorry, PowerShell process running. This is the malicious C2 running on any host, so this is how you would have found Poshy 2 back in 2016. So if from a defensive perspective, they knew that something had been compromised, they knew that PowerShell was running, what they would do to try and find out a little bit more information is the command line arguments. So anything with the -e flag is generally malicious or mostly malicious. And what that is just a basic 64-encoded blob of data. So this is what it looks like, a lot of data. No legitimate process is really running things like this nowadays. And what that means as well, because it's base 64, as we know it's only encoded, you can reverse that, and you can quite happily get basically the dropper, or the Poshy 2 implant, back in its raw state. So you can see the command and control frameworks that it's sort of beaconing to, you can see the crypto that it's using, and you can see all of the data from the dropper perspective. And what that meant was when sort of the EDR sort of timeline came along, was if you do a quick search across your entire estate for the process name PowerShell, basically you can find all of our implants. So from a defense perspective, once EDR became a thing, we kind of had it up our game, because this is how easy it was to kind of find where we'd been across the entire estate once they've got this good visibility of all our endpoints. And then they can dive into any one of these and see the command line arguments, reverse those command line arguments, know where we're beaconing to, and block those beacons. Bang, we're out. That's how quick it can be from a defensive perspective to stop an attack if there's running things like PowerShell, as long as you've got the right things on the host, like EDR. So I guess at this point, the approach was more block PowerShell on all endpoints, don't let PowerShell run. That's the fix, that's easy, happy days, we're all a winner. Only allow signed PowerShell scripts, so they're not going to be signed, so if they can get them in any way, they can't be ran, because PowerShell's blocked. If they can get around that, then they can only run signed PowerShell scripts, so it's a winner. I guess the modern approach now is actually not that, it's more upgrade to PowerShell 5, which has greater visibility. So let the attackers in, let them run those one-liners, and then detect them once they're in sort of mid-stage of their attack, so you can actually see what they're going after and what they're looking for in your estate. So things like AMSI integration with AV, so that's now in PowerShell version 5, the transcript logging, module logging, and script bot logging. So if you run Poshy 2 in PowerShell 5, you will see every command that's ever ran. So that's the kind of visibility you have with all these extra features in PowerShell 5. Having said all of this, back in 2018, FireEye did some really great research, and according to FireEye, APT33 had been basically compromised in lots of different aerospace industries across 2018. Some actually really good blogs if you're interested. So Poshy 2 has been noted to be used. This is literally the PowerShell version as well. So this is the very original PowerShell dropper, not the Python server, which has got a little bit better, not the Reflective DLL. They are literally using the PowerShell one-liners to compromise organizations across the world. And its suspected attribution is Iran as well. So if you want to take a look at that, it's quite an interesting few articles. So it brings me on to sort of the .NET assembly. So what is the PowerShell executable exactly? So basically what that is, as I said before, is a wrapper for the .NET Automation DLL. And what you'll see, if you look in sort of Process Hacker or Process Explorer, and you look at a PowerShell binary when it's running, you'll see these two tabs, .NET Assemblies and .NET Performance. So what that will show you is that it's loaded the CLR inside of that process. And in this version, it's PowerShell version 2, or sorry, this CLR version 2, which is in effect PowerShell version 2. If you look at the modules loaded, so these are all the DLLs that are loaded within that process, you'll see the management automation. That is always loaded within a process that's running PowerShell. You can't get around that. Carbot.io has done some quite good work on how you could maybe manipulate that, but it's not trivial at all. So anything that's running PowerShell or anything in unmanaged world or PowerShell will always have the system.management automation DLL, and that's a great way for detecting it. So this is when we introduced the Reflective DLL, which we talked a little bit about from the Stephen Fewer stuff. So that basically is loading the .NET version 2 CLR inside of unmanaged code. So unmanaged code is basically the C world instead of the C# world. And again, this is code that Stephen Fewer has done work on. It's loading the version 2 of the CLR. So what that does as well, if you're running on a host that has version 2 and version 4, which is quite common, except for version 10 now, which has actually removed support for .NET v2, it allows you to basically remove all the AMSI integration, all of the transcript logging, script.bot logging, because you're loading version 2 of the CLR and not version 4. So these are kind of things that you can do on a host. If you know they've got both of the versions, run the downgrade attack. All of the common scripts like PowerView, all those great tools out there that you want to use are all written for version 2, so there's no point in loading the version 4 of the CLR. But this is quite, how simple it can be to code this up into a reflective DLL. Also, an app domain. So an app domain is, in the .NET world, is where they store all the binaries in a simple app domain. So it keeps it all consolidated into one app domain. You can have multiple app domains inside of a process, but in this instance, we keep them all consolidated into one, because that means you can garbage collect them at the end and sort of remove that whole app domain. And then what we want to do is basically load that app domain. So in the Reflective DLL for Poshy 2, we have two options. You can either load the version 4 or the version 2 of the CLR, depending on what you want to do. So the version 2 will just be loaded directly, or the version 4 will try version 4. If for some reason version 4 isn't available, it will fall back to version 2. So what that means now is, if you take a look at this process listing, can anyone tell me where Poshy 2 is hidden in here? Well, actually, it's really difficult. At this point, there's no way of knowing which process we are in. There's no PowerShell.exe process running. So this makes it a little bit more difficult for the defenders to actually find us inside their network, unless they've got some really cool things like sysmon or EDR on the endpoints that can actually see the processes loaded. So take two NetSH executables. One's a legitimate one, and one's that we've migrated Poshy 2 in. So it gives us full command and control over the endpoint. The only subtle difference is one's got the system.management automation DLL loaded, one hasn't. That's the only way of telling whether this process is malicious or not, from a Poshy 2 perspective. Another way is also whether it's got an app domain. So no NetSH process should have an app domain loaded. It's not a .NET binary, it's a C binary written from Microsoft. There's no good reason why it should have the .NET app domain loaded, and there's just a good way of telling basically if something's been compromised or not. But again, you need to have all these tools on the endpoint to be able to see this. If you've got nothing rolled out and just basic AD on an endpoint, there's no way of knowing at this point whether you've been compromised in a network or not. However, again, with the likes of EDR, providing they've got things like tracing in Tanium enabled or Carbon Black, you can basically go, right, tell me across my entire estate where the system.management automation DLL has been loaded inside of a running process. So if you do that, again, you will find every process that we're running in. Again, you're probably going to have a lot of other processes legitimately like PowerShell. So you need to start excluding things like PowerShell, because at this point you're not looking for that. You're looking for anything that's loaded outside of PowerShell, and this is the kind of response that you'll get. So you've now noticed across your estate that there's 4 processes running that shouldn't have the system.management automation DLL loaded. Another sort of offset consideration that we've kind of moved along in the timeline of Poshy 2 is add type and assembly load. So a lot of processes, a lot of good PowerShell scripts that people write do add type, and there's a good reason for that. They do it so they show you the code, so they're not just putting a big blob of base64 and then doing assembly load. They're actually showing you the code and then you're compiling it on the fly. However, from an offset perspective, If you're running this inside of POSH 2 inside of, say, a NetSH process, and you do add type on your PowerShell script, what that's doing, as we can see here, it's quite small, but it's actually running CSC, which is a command line compiler for C#. It's compiling that bit of code on the fly, and then it's dropping things to disk, like temporary CSC files, and dropping a DLL to disk. So all this is happening in a flash of a second. You won't even notice it when operationally. You'll just think, hey, it's worked, great, carry on. However, if they've got things like Tanium, and they're looking out for things like .csc, .tmp, .dll, this is, again, another way that you can get caught. So making sure that you convert all of your scripts to basically compiled code using assembly load is the way to go. So these are how the things that we've got to adapt to our surrounding, depending on the type of client that we're going after. Another thing that's quite interesting is the assembly load. So assembly load is obviously the way you should be going. However, AMSI is starting to have integration within that. So XPN's did some work around the early release of this for Microsoft. So Microsoft are looking to put basically AMSI into anything that's loaded from an assembly load perspective. And this is basically an early release, so it's worth just checking out his code and when they actually release the code, whether we can get out of it. A lot of this is basically built into your process, though, so a lot of the AMSI and hooking and things like that, the reason why it's an issue is because it's in your process. And Doug will talk a little bit about that sort of in his next phase of EDR and next-gen.
Thank you very much. For those that sit at the back, there's actually seats down the front if you want to grab a seat. There's stand from there. So EDR, basically sensor agent deployed to endpoints that then send a lot of information back about behavior, what's happening on the system. It's got so much more knowledge about what's going on in the system, much more hooks into what's going on. It can put out nice process listings, so when a Word document or a macro runs, that executes. It then launches WScript to run a shell command and then downloads something and executes it. Well, that'll all be in a nice hierarchy tree, and we'll see what some of that looks like. But basically, it gives the blue team so much more visibility. Some of the example vendors you've probably already seen, Carbon Black, where you can search for the system management automation DLL. We've got things like Cylance, Lunison, semantic endpoint protection. So endpoint detection, before EDR came along, the blue team kind of head in the sand, didn't really know what was going on, looking for things like Ben's mentioning there with PowerShell one-liners. But bringing EDR in, when I'm breaking into an organization, doing a process listing to see what's there, doing a bit of recon when I get on the host, and I see EDR, this is pretty much me. I don't want to be in an environment with EDR where someone's got the capability to monitor a lot more about what's actually going on. A lot of the things we're actually doing, we're finding ourselves going back in time, almost like game hacking for some of it. So, avoidance, first and foremost. We've got a number of TTPs and IOCs that we'll follow. So when we're doing threat intelligence by red teams, we're actually that intelligence will indicate what level of threat actor you're supposed to be simulating, and then you go in and follow the same types of TTPs that they do. So one engagement we were on, Carbon Black detected us, so we're migrating to SVC host to force outbound connections through signed Windows binaries, so we don't have an unsigned binary connecting out, because that's a signature of our Carbon Black. So we're trying to hide in there. We use WMI to profile the host, so a bit more advanced, not just running system info and commands that are on there that you might be monitoring for, and dropping files as hidden or system, so that you're hiding them and the user can't see them. So if you're dropping persistence, someone's into a folder and it's hidden, you won't see it without changing the settings. But that led to a detection, and some pretty good assurance exercise from them. Carbon Black does what it said it's supposed to do. But really, when we went back and looked at it and said, we've now got to go back against this organisation, how are we going to go against them? And Carbon Black's got a number of signatures, and a number of feeds that feed in from different places. Bit9, suspicious indicators is one, MITRE ATT&CK framework's another one. They all feed in, and that's what it's doing its analysis with. But actually, just read the fucking manual. It's actually giving away everything it's doing to us as an attacker. So we can go read this and see exactly what's going on and why we got detected. So if we go do that, we've got suspicious SVC host parent, processes sitting hidden in system files, profiling with WMI instead of some of the more obvious things which probably could have got by. So things like system info might have just ran and been undetected, but because we were doing profiling with WMI, it got detected. So when we go back in, how do we do it? Not getting detected. So we already know they opened a phishing email, that we know they've got Outlook open, so we can migrate into Outlook. It's not on a watch list, we know that. We can reflectively load functions, so basically what Ben was saying before, where we had SVC host as a parent, and it was actually launching CSC to compile some of our PowerShell scripts and then execute. We can bypass that by just reflectively loading the functions. We can stop marking files as system and hidden. It's really some of the most obvious things. find alternate methods to query the system, so system info, for example, we could just run that. And then lane persistence, so we can review the watch list to see what it's looking for. If it's looking for startup directories, then we can avoid that. We can start to do things like junction folders with com hijacking. We can start to do word templates. So the word template, the template.doc file that you've got, or the normal.doc, that actually runs is in a trusted location, so any macro put into that will automatically run every time someone runs Word. So we can start to bypass some of these and get by some of them. And then lastly, move to somewhere that doesn't have carbon black. So it was deployed on all the endpoints, but actually the server state didn't. So we can be very stealthy with our methods of getting in, quickly find a way to escalate, and then move directly to serverland and be in a place that they have no visibility whatsoever. And then moving into kind of trickery, we've got a Tanium signal definition. So in this we've got, it's looking for system management automation DLL, which Ben was talking a lot about, but it's not looking for these process list names. And then if you look at number 1 here, it says not doing a hash checksum or digital check on any of the processes in the location. You can see in point 2 why that's actually bad. We can create PowerShell or any of our implants, give it that name, and it will bypass this Tanium alert. Just completely bypass it. So when you know what's going on, it's much better. So again, trickery, parent spoofing, and again, none of this is new. This has been about since 2009. For Dear Stevens talking about it here in an early blog post. It's in almost every C2 implementation. In POSH, it's in POSH as well. So we've got migrate proc path. That's going to run search protocol host in a suspended state. It's going to use the reflective DLL injection into that. And then it's going to give it a parent PID of 432. And that's exactly what we see here. We've got Explorer now launching search protocol host. And again, if you're looking inside something like Process Hacker or Process Explorer, then you'll see it. The parent is Explorer. So kind of tricked where it thinks it's been launched from. If we look back at that example where you're going through Word documents, and you've got Word in a macro W script and then launching your binary, well, if we can trick the computer into thinking where it actually got launched from, then we're jumping into Explorer. So we're removing attribution to the attack path that actually played out. And again, just to prove while we're doing this, we're still actually leaving the same IOC, so we're in the CLR4. We've got system management automation inside our implant that's now running. And this is some of the code that's actually in a DLL, which if you go look at POSH, it's open source, so you can look at a lot of the code. The DLLs are obviously compiled, so you can't. But we've got startup info X, LP attribute list, and inside that we've then got procs red attribute parent process, which allows us to basically specify the spoofed parent that we want to come from. And actually it's taken from Stack Overflow if you look at that right there. So again, this is carbon black, and this bypasses carbon black, or like tricks carbon black into thinking where it came from. So we're now inside explorer.exe as the SVC host in this example. So it's not working out where it's actually came from. It's missing the attack path. So as a defender, when you turn up at your workstation to look at it, to see what's going on, you're doing your forensics, you might miss this bit. You might miss actions that have then happened. And that's what we're looking to do. We're looking to play it in with EDR on the host, but get round some of it and bypass it. So there are methods for detecting parent spoofing. Countercept brought out a blog about 6 months ago, and this is using event tracing for Windows. So at the very top, you've got the header field, and that contains the process ID, and that's actually a parent process for anything that it does. So when it has a task, which is in green here, you can see that the parent process ID inside that 9224 actually matches the header 9224 in red. But when you actually spoof one, what actually happens is we've got a process ID in the event as 4652, and if you look at the header, it's 9224. So those should always match, and they don't, so it's been spoofed. So now we can start to write alerts for that as well. Another bit of trickery, process argument spoofing. Has anyone seen much about this? No? So inside a process, you've got the PEB, process environment block, and that tells you a lot about what's actually inside a process. It's got a lot of information about that process. One of the things it's got is RTL user process parameters, or the process parameters, which has got another structure which you can go parse, and inside that's the command line. So the way we can abuse this is basically we can create a process that's suspended, that's got an argument. So we can have like command prompt and launch in, say, just a string. And then we identify where the PEB is with the NT query process information. We then parse the PEB using that structure, pass the command line arguments, and then we can overwrite the command line arguments with whatever we want using write process memory. So we're going to patch it in memory while it's in a suspended state. And then when we resume it, what actually gets kicked off is what was there just as you were about to resume, what the command line arguments were. But what's actually recorded by Windows is what happened when it was created, when it was in a suspended state. So you can have fake arguments at the start, and then your real arguments are updated when it's suspended. So we've got this in a lot of our C2 tooling. Some of the things like Posh, that's open source. Some of the other tooling we've got is not open source, and only our customers get to see it when they do. But I found a couple of good examples online. And Cobalt Strike's got this with argue as well as a statement, where you can do spoofing. XPN also brought a blog post out with an example proof of concept C++ app to do the same thing. And then, but the one I like the best is FuzzySex Swamp Thing, which is a C# implementation. And we're just going to do a quick example of what that looks like, or at least some pictures. So we've got what Swamp Thing's going to do is it's going to launch command prompt. It's going to echo out hello sailor as fake arguments, and then it's going to have real arguments of hello BSides. So what we see when it actually pops is hello BSides is echoed out. So that's what's actually executed. But if we look inside Process Hacker, we actually see the command line says hello sailor, because it's tracking what was done at the initial stage, not what was done when it was resumed. So again, you can trick things in. You're probably thinking, sorry, I jumped ahead there. So for this bit, there is a warning. So certain process explorers, things like Process Explorer from sysinternals, actually go and read the PEB that you've updated. So if you don't modify it, or once you've modified it to the resumed, it's going to be the real argument, so they can be leaked. However, Swamp Thing actually does something really cool. So when it creates it suspended with the fake arguments, then it changes the arguments and then resumes it. It then changes into the fake ones again, so anyone who goes along to look afterwards doesn't see anything. But you're probably thinking, why are you doing this? And the real answer is PowerShell one-liners, for example, where all that minus E would just disappear. You can make it look like whatever you want, so it would still launch PowerShell and you might get caught for that. But all that extra stuff's gone. Same with these extra additional execution methods. And then lateral movement, sometimes when you break into one host and you're moving to another, you're actually trying to remove attribution to how you got in, and you might have two C2 implants going out on two different URLs to just minimize everything that they can see. So if they see one and take that away, you're still actually in there with a separate infrastructure. So if we can say that SC was ran, but they don't see the computer name, then great, they don't know where we went. So inside userland, you've got your processes, so you've got a user process, and this is all kind of in one process, but I just wanted to kind of illustrate it out. It's maybe not perfect either. But you've got a user process that calls virtual alloc x, which then calls ZW allocate virtual memory, and then that talks out through syscalls to the kernel, and that's where your action's then actually carried out. So all the Windows API calls have to go through that. But this is where it kind of gets like old school gaming, is when you're talking about hooking. So hooking is really manipulating the logic flow of something that's going on and then being able to intercept that and make modifications to it. So another quick example of that is, this is just Visual Studio with some C# code in it. But when you put the red dot there, that's a breakpoint. And that's actually injecting CCs into memory at runtime. And that's not unlike hot patching or hooking, because you're actually manipulating the way that flows. So it's just a really quick, easy example. But if we look at what EBR is actually doing, it's when you go from virtual alloc x to ZW virtual allocate memory, we've got the trampoline that's going to happen into the space where that actually is. It's a jump address, so you've got a jump table. So the jump table is updated by EBR, and then they control that. So anything that's coming through that, they can now check if it's good or bad, if it's malicious or not, and then pass it on to the kernel if it's good and terminate it if it's bad. But there is a problem here, and I don't know if you can see what it is, but really it's all happening in user land, so it's not happening in the kernel. So actually, all the stuff that they're doing, all the modifications they're doing in your process. So they're injecting their DLL in and then redirecting them to the functions that they've put there in your process. So from our perspective, we can pretty much say, what the fuck you doing in my house? That's my process. I own that process. You come into my process. So what we can actually do is repatch memory to remove jump to the original code. So it's in our own process, so we can do whatever we want with that. We can update the import address table to point to the correct function. We can create a stub to carry out the syscalls and then jump to that stub, and that does it instead. We can also use free library to remove some of the libraries and DLLs that they've injected in. So I've got a quick demo of what that looks like, just because that probably sounds a bit wizardry, and it certainly does to me sometimes too, but it's not actually that much code and that much work. So this little demo we created a DLL that takes two variables. I've got to also say thanks to Rob Maslin for the help with this, but it's got a hookable function. It takes two variables and does some basic math on it and gives you an output. So the first run of it, this is just in C#. We're just going to create a class. That's going to load the DLL. Hopefully you can see it okay. It's going to declare the DLL function, hookable function, and then we're going to call it in the main. We're going to give it 10 and 11 as two numbers. It's going to do some basic math on that, and it's going to output a result when we click play. So, yeah, we get a result, 122 comes out. And actually, if we run it multiple times, 122 will keep coming out. It's just static math, so we do that quick test. But now what we're going to do is we're going to hook that function in memory. So we're going to load it, then hook it, and we're going to redirect it to our own function. And this is basically exactly what EDR are doing. And then we're going to control the flow of the data and flow of the function, so then we can do whatever we want with those numbers. So we're going to do some different math and just add them together and add 62. That result will end up being 83. So if we quickly look at what that looks like, we create a class, and then we create our own function. So this is just a similar function. Takes two integers. It's going to write out the integers that came in. So again, it's just to show that we can control it. And then at the very bottom of that function, we've got return key plus value plus 62, which is where we're doing our own math on it. And then we're going to go and work out exactly where that is in memory. And just before, we've got some additional DLL imports here, which are going to be where we call the Windows API calls in. So we've got things like load library, get proc address, pre-library, and write process memory. So that's actually the only API calls we need to do this. We're then going to jump back up to the main, and we're going to look at how this actually plays out. We're going to load the library function in, and this is the hookable function. So this is the initial one that we did earlier on, the earlier run. We're then going to identify where that is in memory using get a proc address. Then going to work out the offset of where that is versus where our code is in memory, and then we're going to use write process memory to then update in memory where it thinks it's jumping. So as I showed you that jump instruction that's there before, well, we're just going to overwrite the jump instruction. So we get the base value in the +1 because it's got an E9 for a jump, and then that's going to then jump to our own code. And then we're going to click play, and then we're going to reset it back to the initial one. So what we should see when we click play this time is the value has been, we'll say it's been hooked, we'll see a math function value that comes out with 83, and then we'll see a math function value that comes out with 122 after it's been unhooked again. And really the take home from this is just how easy it was to manipulate this in memory, and that's exactly what EDR is doing, and it's exactly what we're doing to unhook EDR. There's been some really good work by people like XPN recently unhooking things like Silence from inside your process. We've been doing a lot of work. If you look through some of Nurtured's blogs, you'll see people like Tom Wilson are putting out things that turn a vector into a paperweight. So we've got a lot of power when people are actually using this in user process space, because it gives us a lot of control. So, and just summing up, EDR, it's not a silver bullet. People tend to think it is, and they quickly deploy it to all of your endpoints. It does give incredible visibility to the blue team. Highly recommend as a complementary piece, and that's the key. It's a complementary piece to your defensive strategy. It shouldn't be solely relied on. And then it does not replace good people with experience. That's still the best thing you can have inside your team, inside your security teams. And then it's always going to be a cat and mouse game. They're always going to do something. We're always going to do something. They're always going to go create this new security mechanism. We're going to look to get by it.
Yeah, and I guess it just brings us back to, I guess, the reason why we're here today, and it is PowerShell dead, and this is my attempt as no is not nay. That's Doug's Scottish for no, I think, so that was relevant. But if you do think PowerShell is dead, and I guess it does depend on the environment you're going after, so it depends on the sophistication of the endpoint, it depends on if they've got EDR, if they've got Sysmon deployed, if they've got Tanium, what kind of logging and monitoring they've got on the endpoint, how you're sending in the payload, because a lot of sort of common scripts and security appliances are now looking for the word PowerShell.exe, so it does depend on how you weaponize something and deliver it into an organization to whether you use PowerShell or not. But if you do think PowerShell is dead, we're kind of getting with the crowd, and we implemented a C# implant. I'm not going to go too much into town about it, but just going to give you a quick run through of if you want to have a go play at home. So once you set up Poshy2, which is quite a trivial install, on a Linux machine, you'll see these 2 bits of code, which is basically the Sharp implant, and it's all in version 4 of the CLR. We haven't backported it to 2, because all the common libraries and stuff that we need is generally in 4. And there's a quick way of getting this going. So if you're on any Windows box, once that has visibility of the Poshy2 server, you can run it with this void func as the entry point. So that's your entry point to start the DLL. So that should just kick you off a shell. And if you want to, you can migrate to something like search protocol host just to prove that you're not actually in a proper C# binary, you're in an unmanaged process. So what does that look again from a defensive perspective? So we're in search protocol host as we just migrated to. How can we tell now that it's actually a malicious binary and again not PowerShell, and it's actually purely just C#? So again, it will have an app domain that we saw before, so very similar. It will also load something called CLR.dll and the mscoreee.dll. These are the 2, I guess, signature libraries now that got loaded. So it's not the system.management.automation DLL. However, there's a lot of other legitimate binaries out there across your estates that will be running things like the CLR. Lots of applications, even things like Cylance, are running sort of based on .NET. A lot of other programs like Link also have tie-ins to MS-Core-EE and sort of the CLR. So although you can do the similar thing, like looking at the system.management automation DLL, from a C# perspective, it's a lot harder because this is a lot more prevalent across your estate. So it's not quite as simple to do that. One of the things I guess I wanted to say as well about the C# implant is, so everything was based on PowerShell originally. So obviously PowerShell is a command prompt, so it has things like change working directory, print working directory, echo, things like copy. All those things on a C# implant isn't native, so we had to actually build all that into the core implant. So that's why a lot of like common features and things like that weren't there by default, and we had to build all these. One of the things that we've actually done, which is using .NET Reflection, is allow you to load, though, any binary. So I don't know if you're familiar with Cobalt Strike and its assembly, execute assembly function. This is sort of a similar concept on that. So any of the sort of ghost pack executables or DLLs that you can get out there from the community to use offensively on your red teams, basically you can load into Poshy2. So get one of these processes running, go and compile your own .NET library, and you can load it like this using load module, and then the executable or DLL, and then do run exe or run DLL. So here's a quick example. So there's 2 options, run exe and run DLL. You have to give it the namespace name and the class name, and then plus the namespace again, and we'll talk a little about why, and then the method. So if you're running a DLL, you have to give it a method because it doesn't have an entry point. If you're running an exe, you don't have to give it an entry point. You don't have to give it a method because it has a default entry point of main. So what does that look like under the hood? So basically what we do is once you load an assembly, it uses assembly load like we talked about earlier, basics to a blob, and loads it back into the run space, and you can see it, which we'll show you in a sec. And then if you're running an exe, it'll go away and run basically invoke, which is the entry point of main. So any main, so if you give it an argument and it's got an argument parser, it'll be in there, so you can just give it -h, and it'll show you all the help. But with the DLL function, you need to actually give it a specific method that you're calling in any parameters or arguments that you want to pass to that as well. But it allows it to be fully extensible, so you can go and write any C# application and use it via the C# implant based on its .NET 4 or above, basically. So it's really quite powerful, but sort of like the default, it kind of gives you the crux of an implant, all the comms, upload, download, the basic features, but you can now go away and create your own sort of core DLLs, own process migration methods, anything you want, all written in .NET, and it allows it to be fully usable within the implant. Just to show you a bit of an OPSEC consideration, again, when you load something like seatbelt and the assembly name is called seatbelt, you will actually see it. Sorry, I'm getting a timeout now, so just speeding up now. Yeah, you'll see seatbelt in the assembly app domain, so just things to be aware of. Last slide now. Just a bit of future prediction. So, as Doug sort of said already, there's a bit of an over-reliance on EDR, on the endpoints. A lot of people are focusing on all their tertiary assets and probably not enough on their core systems, all their critical data, all the customer data. So I kind of moved to zero trust networks and MFA, we believe, machine learning. So I think a lot of people are going to invest a lot more time into their people and process. If you can really get a handle on all your processes and how they sort of administer systems, an attacker isn't going to know those. So from a behavioral analysis perspective, you're able to know if something is being administered in a different way and know that's an anomaly and potentially the start of an incident. I think C2 framework's going to sort of move back to the sort of C++ base. So .NET frameworks, PowerShell, are all going to start probably going back to sort of the core C libraries, things like dropping executables onto disk rather than actually running things like the lolbas and lolbins. So they were great at a time, but they're a finite list. So if you're actually dropping things like MS Build or CSC and running them sort of in a malicious way, they're going to know about them and Tanium and things like that can pick up on those really quickly. So if you're running things outside of that, then they're not likely to get signatured. So chucking something like an arbitrary executable onto a host sounds really noddy, but actually probably gets around a lot of these security products. That's pretty much all we've got time for, I think. But thanks for your time, and I guess I just wanted to leave you with, find a job that you enjoy doing and you never have to work a day in your life. The final keynote is in track 1 as well, I believe, and it's when starting now. Sorry, we have run over. The slides are there if you want. Thanks very much for your time.